How to perform calculations using integrated rate equation. When we use integrated rate equation or the half-life equation, okay, if you can determine the order of reaction, it will be one of your success criteria. Okay, you can also determine the concentration at any given time, then the value of the rate constant, half-life, and time for reaction. Now let's look at some examples. Okay, just a reminder, only for first order reaction. Okay, for first order reaction, if let's say the initial concentration is not given, then you can assume the initial concentration is 100% or 1. Okay, then there's one more thing that I would like to remind you, that is T. Okay, or sometimes they don't label T, they just leave it empty. Okay, so this part is referring to the concentration of reactant that remain left over or is final. It doesn't say that it is not representing the amount of how much reactant has reacted, consumed, depleted, or decomposed. These are the usual words that to describe the process of reactant A. Now, let's look at the question given. The decomposition of SO2Cl2 is a first order reaction. So this is an important clue because you are going to use the integrated either half-life or integrated rate equation must refer to first order reaction. Okay, so the first part is asked to write the integrated rate equation. So if this is a first order, okay, so you have to write for the integrated rate equation for the first order. Okay, then some of the students, they will just simply write any of the concentration. Okay, remember, we always refer to reactants, and then integrated rate equation only refers to monoreactants. Okay, so now we substitute our reactants into the integrated rate equation for first order. Okay, then remember to label initial, okay, 0 here. Okay, sometimes, like I said earlier, you can leave it empty or you can label T. Okay, now the problem with students is they use the general one, that is, they use A. Okay, you are not allowed to use A. It is incorrect because now your reactant is not A. So if you label as long concentration A, then it is incorrect. Okay, next one. Calculate the value of rate constant K if 5% decompose in 6.75 minutes. Okay, now this is a first order reaction. Okay, so remember, first order reaction, we need to have, okay, if we look at the integrated rate equation, we need to have initial concentration. However, the question did not give any information about initial concentration. So we can assume the initial concentration is equals to 100% or 1. Okay, since here is used percent, then we use 100%. Remember, it's only for first order reaction. Okay, so label one by one. Initial concentration, 100%. Okay, now this is the tricky part. That is the concentration that remain or final. Okay, look at the question. 5% decompose. So your remaining is 95%. Okay, some of the students, they don't understand that the 5% decompose is the amount reacted. So what they do is they just put final is 5. They just put here final is 5%. So this answer is wrong. Okay, now time is given 6.75 minutes. Okay, so what you do is the next one is you just substitute into the integrated rate equation, you can choose this format or another format. Okay, it's actually the same mathematic. Okay, now the rate constant, it didn't mention about unit, right? But rate constant must show unit because the unit represents the order. Therefore, you must give the unit for rate constant of first order. If first order, it must be per minute or per second or per hour. Okay, depends on the question given. Okay, the question gives minute, so we use per minute. Okay, now next one. Calculates the time needed for the initial concentration of 0.1 molar to reduce to 0.04 molar at 500 Kelvin. Okay, now this time initial concentration is given. So you use 0.1 molar. You cannot use 100% anymore because initial is given. Okay, then there's one important keyword here, that is, it says reduce to. Okay, so reduce to means that the leftover or the final concentration is 0.04. If you use 0.1 minus 0.04, then it is incorrect because the keyword given is reduced to, not reduced by. Okay, then after that, okay, you need rate constant, right? Okay, rate constant just now we have calculated, and rate constant calculated is the same unless temperature changes. Okay, if temperature is the same, then rate constant is the same. Okay, then you just substitute, and remember time you must give unit. Okay, now next one. Okay, calculates the concentration of reactants after 5 minutes. Okay, now given if initial concentration is 3.0 molar. Okay, same thing, it is not 100%, okay, because it's given. Okay, so then you just substitute, and remember concentration must have unit. Okay, the concentration after means that you want to find the leftover. Okay, another one. Calculates the half-life of the decomposition of the reaction. Since this is a first order reaction, you must memorize the formula for half-life. Okay, and then remember to label half, D half, which students often left out the negative, often left out the half. Okay, so you have to memorize it and then substitute and you will get the answer. And remember, time, half-life is time also, so you just use minute. Okay, what is the points to remember? Okay, so rate constant unit, you must follow the order of the reaction. So you means that you must memorize what is the unit for zero order, first order, and second order. You can only assume initial. Okay, it should be zero here. Okay, you can only assume the concentration, initial concentration for first order reaction if initial concentration is not given. Okay, another one is students' weaknesses is they do not understand the term. Okay, for example, concentration of A reduced by 20%. So the remaining one or leftover is 80%. If reduced to means final, okay, straight away you can use it. Okay, for example, another one. If we have second order, we cannot assume it as 100%. 100% is assume only for first order if not given. Okay, then here, again, the same thing, by. Okay, now, so you need to understand the keywords. Okay, must memorize all the formula because from the units of rate constant, you will know that it is first order. Okay, from the order of reaction, you will also know the units for the rate constant. And remember, the time can be second, minute, or hour. Okay, so this is the summary of what you need to memorize for all this. Okay, the Rate's law, units for rate constant, integrated Rate's law equation, and the half-life. Okay, so that's all for this part.